Hello.
Yes, sir.
What you did?
First found the number of subsets E2, sir.
Mm-hmm. Okay. So let me just explain the thing. How we do it. So the idea is this. What we are going to do is, you notice that the E1 is given 1, 2, 3, F1 is 1, 3, 4, and G1 is 2, 3, 4, 5. This is the given information. Now two
Yes.
elements are chosen random without replacement from the set E1, and let S1 denote the set of the chosen element. So instead of saying that S1 is indicating the subset containing two elements, this question is saying in a different word. So you can notice that the S1 can have three choices, like S1 can
Yes, sir.
have three values, like
1, 2,
S1 can,
1, 3, or 2, 3.
yes. So S1 will have 1, 2, S1 can have,
Sir, the screen is not visible, sir.
oh, not visible, okay, wait. Now it's visible?
Yes, sir. Now it's
Yes,
visible.
yeah, so S2 can be 1, 3, and sorry, not S2, S1 can be 1, 3, and then again S1 can be 2, 3. So these are the three possibilities we have.
Yes, sir. So
Now what?
E2 can be 1, 2, or 3, sir. The subset of E1 with one element.
Okay, good. So E2 can be, by the way, this is not here set. This will be like this, okay. So E2 can be, so you also notice one thing. Let me write S1, S1, S1 in that row wise, so that will be easy to calculate. So S1 is now 1, 3, and S2 will be, sorry, S1 is again 2, 3. So this is the first scenario, this is the second one, and this is the third one. Now when you proceed for that further, what do you observe? The E2 is E1 minus S1. What is the meaning of this?
Sir. The element in E1 which is not in S1.
So what you get, like, can you write the E1 is again E2 union S1?
Yes, sir.
Correct?
Yes, sir.
Okay. And at the last, what they are saying, E1 is equal to E3.
Yes, sir.
Correct? And what is E3, by the way?
E2 union S3.
So there is a crucial information. You notice if you just take this again, E3 is equal to E2 union S3.
So
Now
S1
can you
will be
say,
equal to S3.
exactly, very good. It means I can say that S1 is equal to S3.
Yes.
Now can you tell me what conditional probability they are asking?
S1 is 1, 2.
S1 is 1, 2 provided or given that?
E1 is equal to E3.
Means E1 is equal to E3 now leads to S1 is equal to S3.
Yes.
So can we now conclude that they're asking the conditional probability of what?
S1 is equal to S3.
No. Probability that, see here, finally two elements without replacement and so on. Let P be the probability that event S1 here, let E3 is equal to this, given that E1 is equal to E3. So basically what they're asking that S1 is 1, 2, provided given that E1 is equal to E3. But E1 is equal to E3 is equivalent to
S1 is equal to S3.
So can we directly find that we have to find out what probability of S1 is equal to 1, 2?
Given that S1
Given
is
that
equal to S3.
S1 is equal to S3. Understood?
Yes, sir.
Okay. So that's the thing I have to evaluate. What do we do after this? Can you just use some information to do that? Notice what is happening at the second level. Second level, what is happening? You have S1 here, 1 comma 2. Can we construct F2? You notice two elements are chosen, so we have already done E1 and S1 denote the set. Okay, that's okay. E2 is what? E1 minus S1. So whatever
Yes.
E2 will left over. What is E2, by the way? In this case, E2 will be 3. First
3,
case.
then 2, then 1. 7.
Yes. So then 3, 2, 1, you are actually combining with again F1.
Yes,
F1
sir.
is here. So can you directly say that what is F2? Let's say I'm constructing F2 here. F2 is nothing but what is that? F2 is
F1 union S1.
F1 union S1. Very good. So F1 union S1. So can you say in all these cases what is F2? By the way, F1 is 134. Let me write it here.
Yes.
When I'm scrolling it up, it's not visible. Okay. So tell me, what is this?
It will be 1, 2, 4, sir. 1, 2, 3, 4.
1, 2,
In
3,
the
4.
first
Very good.
case.
1, 2, 3, 4. What about this thing?
1, 3, 4.
Only 1, 3, 4 we're getting?
Yes, sir.
Okay. And what about this thing?
1, 2, 3, 4 again, sir.
1, 2, 3, 4. Correct? So we got
Yes,
the
sir.
set of F2. Now two elements again are chosen at random without replacement from the set F2. And let S2 denote the set. Okay. And G2 is G1 union S2. What is S2? S2 we have taken from here. And G2 is
G1 union S2.
and finally I have S3. Correct?
Yes, sir.
Now S3 wants to be S1. Correct? So we first fix this thing. And this again should be 1, 2. Correct?
Yes, sir.
So if this wants to be 1, 2, it means one should go through S2 to G2 to S3.
Yes, sir.
Correct?
Yes,
You
sir.
understood what I'm saying? Yes. So how do we get this thing? This has how many choices? It can be 1,
4,
2.
sir.
Huh?
Sorry. 3 choices, sir. 1, 2, 1, 3, and 1, 4, sir.
3 choices is there. S2 I have. What are the choices? We can take like let's say 1 and comma and this any number, let's say X, which
Any
is
numbers.
belonging from belong
2, 3,
from
4. 2, 3, or 4.
2, 3, 4. Correct? Like
Yes, sir.
so in this way, what we can make the number of ways here to choose this thing, to get this thing happen. 1 you have chosen, and out of 3
Yes,
you are
sir.
choosing 1. So there is a 3 ways. Correct?
Yes, sir.
And what is the probability if you ask? Suppose you want to find the probability of this. It's a branch like this, S1. And in this branch, I'm finding the probability of this. And again, proceeding this probability to get this one and proceeding to get this one.
1 by 2, sir.
And this is 1 by 2, no? You are choosing 2 items out of 4 items.
Out of 4. Yes, sir. 4C2, sir. Which will be
And
6. So 3 out of 6 will be 1
that
by
is
2.
1 by 2. Very good. So 3 over 6, that is going to be 1 by 2. So this probability we got 1 by 2. What
Yes,
about this thing? When you are taking the combination of G1 union S2. So S2 whatever comes, let's say 1 comma 2 is coming, and you are combining with 2 3 4 5, what you get the G2?
1 to 5, sir.
1 2 3 4 5. If you take 1 3, then
Regardless of
again
whichever X we choose, it will always be
exactly,
1
very
to
good,
5.
very good, very good. So if you take this, any of them, this will give you 1 2 3 4 5.
Yes, sir.
Is it okay?
Yes, sir.
Okay. Now, out of this 1 2 3 4 5, whatever happens, from there I have to have the 1 comma 2 only, the subset. So what is the number of ways of doing this thing? Out of 5, you are choosing 2, but favorable outcome is only 1. That is the 1 comma 2.
Yes, sir.
So what I can do? 1 by 10.
1 by 5C.
1 by
Yes, sir,
10,
1 by
correct?
10.
1 by
Yes,
10.
sir.
So this probability we got, so let me write, okay, so anyway, this is 1 by 10, this is the probability, correct? Now, suppose I combine all these things, what we get? 1 by 2, 1 by 10. By the way, if someone says that, okay, I can also choose S1 with the probability 1 by 3, because this is 3 such S1. But that is
Yes, sir.
not important, that's not required, because each one is equally probable, correct?
Yes,
So
sir.
this I can say that 1 by 20, correct? So let's say this is the probability P1, I'm calling it 1 by 20. After getting this, can you
Yes.
suggest, Karunish, what I have to find actually? You notice I have to find this thing 1 comma 2 S3 1 comma 2 matching. See that probability, what they're asking, S1, given that S1 1 comma 2 when S1 is equal to S3. So these are the all possible cases. I'm going to find out the number of like probability in which S1 can be equal to S3. Among those S1 is equal to S3 cases, I'm just intended to find out in which S1 is equal to S3 is equal to 1 comma 2.
Yes, sir.
Understood? So suppose
Yes,
I
sir.
find the probability of this one and probability of this one. After that, what I have to
We
find?
add all of them and divide it by 3, sir.
No. Conditional probability, please understand. You will not understand.
Probability
See,
of S1 being equal to S3, sir.
so how do you find it? Conditional probability. You know that. Just focus and see. You are finding this probability. You are finding this probability. Finding this probability. Then you add them up, and you
Yes,
find what I have to find out of all of this. See, now it's very clear. This is the conditional probability. So what do you do?
probability of S1 being 1, 2.
1 comma 2. It means S3 being also 1 comma 2, na?
Yes, sir.
So, so out of all these probabilities, you are finding this probability. So what do you do? Okay, so let's find first. Then you will come to know perhaps. So for there, what you do? Please tell me. S2, what you can choose? Again, 1 I'm going to do, correct? Because
Yes, sir.
because finally I have to reach to 1 comma 2, or sorry, 1 comma 3 by the
1,
way.
3.
Yes. So in this case, I have to reach 1 comma 2. So 1 should be there in this transition stage, correct? Or transferring
Yes, sir.
stage. So 1 I'm just calling y again, and y belongs to
3 or 4.
3 and 4, correct? Now tell me
Yes, sir.
the probability of this. 1 is already selected, and out
Yes,
of,
sir.
so basically you are selecting 2 items from 3 items, but favorable is
1.
favorable is 1 y, 1 comma 3 and 1
Sorry,
comma
2,
4.
sir. 2,
2.
sir.
So what do you get here?
2 by 3, sir.
2 by 3. So this can be 2 by 3. Probability is 2 by 3. What about this thing?
Again, it will be 1 to 5, sir.
Why 1 to 5? Because 2, 3, 4, 5 already there. So again 1, 3, 5. So let's 1 to 5. Sorry. So 1, 2, 3, 4, 5.
Yes, sir. And again,
And
1 by 10 will be the probability.
again 1 by 10 will be the probability. So again, multiply what you get, P2.
1 by 15, sir.
1 by
15.
15, okay. Very good. Now, for 1, 2, 3, 4, what you get here?
S3 should be 2, 3.
And by the way, here I have 2, 3, correct?
Yes,
Now,
sir.
here there is a problem. Why is the problem? Because this needs 2, 3.
And both S2 and G1 have to come. 2 and
Yes,
3.
so for that, what we need actually, there are two cases in which. What are the two cases? The two cases is, first we can have 1 in the set.
Yes, sir.
The X comes from
2, 3, or 4.
2, 3, or 4.
And this will be 1 by 2. Probability will be 1 by 2, sir.
Probability is 1 by 2. Very good. And here what we get?
And probability that S is not in the set will be 1 by 2 again, sir.
So let's say A comma B, and A and B not equal to 1. Correct?
Yes, sir.
A not equal to 1 and also B not equal to. Means it doesn't mean that A both are equal, but you understood the point. So in this case, what
Yes,
you
sir.
write, what do you get here?
1 by 2 again, sir.
How 1 by 2?
Because probability of 1 being 1 and probability of not having 1 are complementary events, sir. So total probability will be 1. So you can write it as 1 minus 1 by 2.
1 by 2.
Yes,
Now,
sir.
in this case, what we get this
In the first case, we'll get
G2.
to 1 to 5 again, sir.
Again 1, 2, 3, 4, 5, correct?
Yes, sir.
And in this case, the let's say what do we call
We'll
P3,
get-
not P3, I'm saying. Okay. So P, how do we write it? P31, correct?
Yes, sir.
So what is P31?
1 by 20, sir.
1 by 20. And here what we get?
2 to 5, sir. G2
2,
will
3,
be 2
4.
to 5.
Yes. So then I need 2, 3, and I need
1 by
this
12,
4
sir.
C2. 1 by
12.
12. 1 by 12. So what we do here? So 1 by 20 plus 1 by 12. What we get it here?
2 by 15, sir.
2 by 15. Now, what I have to find? Just let the question again was the same. What I have to find out?
Probability of S1 being
Yeah. So the thing is that probability of S1 being 1, 2,
1 by
given that
S1 is equal.
S1 is equal to S3. If I ask you
So
this
1 by
thing,
1 by 20 divided by the whole probability.
exactly, very good, very good. Now you understood. So what I have to do? This is the conditional probability. Now we are taking the part of it
Yes, sir.
under some what we call the new sample space. So we have cut the
Yes, sir.
sample space in which S1 is equal to S3, and among that S1 is equal to S3, I'm finding the what is asking, correct? So here what we get it
Yes,
here,
sir.
1 by 20 on the top and divided by what? 1 by 20 plus
Plus 1 by 15
1
plus
by 15
2 by 15.
plus, please find it.
Five, sir.
5 or 1 by 5?
1 by 5, sir.
So 1 by 5 is the answer. Understood?
Yes, sir.
Yes. So this was considered to be a toughest one because we have to extract the data wisely And also in some solutions we find they have given 1/3 here. But you notice if you take the 1/3, from the top and the bottom, the 1/3 will go away. So in this method, what we are doing, we are just giving the weight to each of the probabilities, and then we are finding the ratio, and this will be, I think, the smartest way to do. S be the sample space of 3/3 matrices with entries from the set 0, 1, and E1 and E2 are the events given by this. If a matrix is chosen random from S, the conditional probability P even given it. So if you want to write E given E2, what is the basic definition of conditional probability? E1 given E2, it means that the probability of E1 intersection E2
by probability of E2.
Probability of E2. Can you tell me, this can be also, because we are only relying on the counting of the such matrices, correct? So we can also take the lighter version of it, like N1 into E1 intersection E2 by N of E2.
Yes.
Now, instead of finding the probability of each of such events, we are now willing to find
Finding
out the number of such matrices we can construct or not, correct? So now number of E1 intersection E2 means what? If you want to understand in a wording, what is the meaning of this? That I need to have a such matrix, the set of such matrix, in which the determinant is also 0 and sum of entry is also 0, correct or not?
Why we should put the sum of entries be 0, sir? 7.
Sorry,
No,
sum of
sir.
entry is 7. Sorry, 7. I mean to say that thing. So means determinant means I need to have a matrix. It's a number of such matrices. Correct?
So the elements will be 7 ones and 2 zeros.
Yes. So let me just such matrices whose determinant is 0 as well as sum of entry is 0. Correct or not?
Yes, sir.
Sorry, 7. Entry is 7. And then denominator, what we have to do?
Number of matrices with sum of entries equal to 7.
Yes. Sum of number of matrices, sum of entries 7.
Yes, sir.
So correct?
Yes, sir.
So we are finding the number of all matrices in which sum of entries is going to be 7. Yes. So sum of entries means 7 means we have to take only 0 and 1. So what are the possible cases you can make?
7 ones and 2 zeros. That's the only possibility we can have.
7 ones and
2 zeros.
yes, very good. So we have 7 ones and 2 zeros. Because we have 9 places, so we have 7 ones and 2 zeros. So what is the number of ways to arrange it? Tell me. 9 factorial.
Yes.
Divided by
7 factorial into 2 factorial.
Very good. So 9 into 8, 7 is gone. And there's a 2. So I think we got 36. Out of these 36, how many such matrices whose determinant is 0?
6, sir.
Which are they? Can you just, what you did?
We need for determinant 0, one of the rows, 2 of the rows or columns must be equal, sir.
2 of the rows and the columns are equal. And also, all the entries of one row or one column can be 0. That is also possible.
Yes, sir, but here that's not possible since we are working with only 2 zeros. So
Very good.
all the rows can't be 0.
Exactly, very good. So
number of ways we can choose is we can have two rows as equal or 2 columns as equal, and in each case we have 3 possibilities. So total number of possibilities will be 6, sir.
I think there is some mistake you are doing. Please check it again. You can actually give the condition on the zeros actually. How can you give the condition? You can make that possible that, okay, zeros, all both zeros are in the one row.
Yes, sir.
So if both zeros are in the one row, then automatically the 2 rows will be identical.
Yes, sir.
Correct or not? And when the 2 rows will be identical, the determinant will be always 0. But these 2 zeros which are, you are going to give some, or let me just write it. The case 1 I can take. Let me write it. Case 1, when both zeros are in the same row.
Yes, sir.
Of course, in examination, you don't have to write all these things, but notice that. So what I mean to say that this is 0, 0, 1, correct? And this is
Yes,
1,
sir.
1, 1, and this is 1, 1, 1. In this case, automatically the answer will be 0. Determinant will be 0, correct?
0. Yes, sir.
But notice one thing. These 3 rows, this row, this row, this row, can interchange among themselves or not?
So 3 ways we can form.
No. 3 factorial
By
divided by 2 factorial. Why? Because 2 rows are integral.
yes,
Correct?
sir.
Also, these 3 elements among themselves can be arranged because there no arrangement possible, or even the possible is to give the same thing. But here the 3 arrangements can be made. Correct?
Yes, sir.
So in each such permutation, I have to include those permutations also in each case. So what we get here? Again 3
Into
factorial
3
by
factorial by 2
2
factorial.
So what we get here? 9 total, correct?
Yes, sir.
Okay. Yes. What is the second case? Can you just see and tell me what you are doing? Tell me. Case 2. What is case 2? When zeros are in different rows, correct?
Yes, sir. Different rows are same column.
Rows we can work directly, column we don't have to work. So this is going to be 0, 1, 1 I'm writing. And again I'm giving 0 here. 1,
Yes, sir.
1, and 1, 1, 1, correct?
Yes, sir. And here again we'll be having 9 cases. Here 2 columns are still identical now, sir.
So what we get here?
I think again it
Nine
will be
again.
9. Yes, sir.
9. Okay. So do you see that these two are identical thing? No. Correct?
Yes, sir.
If I ask you that these two are identical or not? No. By any, I'm asking one important thing. Suppose I make some changes here in rows. Not, I mean, yeah. If I even if I change the rows, do we get this thing by any configuration? No.
No, sir.
See, what I'm asking, I mean to say that are we over counting? Maybe are we counting anything twice by just taking this case and this case? So
No,
your
sir.
answer should be no. No, very good. Because that's why we place this thing in the one row, and here I'm placing in 2 rows. So
Different
even
rows.
if you transpose, yeah, so if you transpose only, that can be happen. But we are thinking in rows only, correct? Not in
Yes,
columns.
sir.
So if you're putting in different rows, automatically the 2 columns will become identical for 1, 1, 1. Correct? And same principle
Yes,
you
sir.
can apply on the column wise. Correct?
Yes, sir.
So again we get how much? 9. So total we get is 18. 9 plus 9, 18 favorable
Yes.
cases. And therefore the answer is 18 by 36.
1 by 2.
Understood?
Yes, sir.
Try. Okay. Let X be a set of all 5-digit numbers formed using 1, 2, 2, 4, 4, 0. For example, 2, 2, 4, 0 is in X and this is not in X. Suppose that each element of X has an equal chance being chosen. Let me the probability, conditional probability that an element chosen at random is a multiple of 20 given that it's a multiple of 1. It's a multiple of 5. So given that multiple of 5, so again we do this thing. Let's say E1 or E is an event multiple of 20.
Yes, sir.
And F is an event multiple of 5.
Yes, sir. NE by NE intersection and F by
So we have to,
NF.
yes, so number of
E
E
intersection
intersection
F
F
by number of F.
and F, correct?
Yes, sir.
So what is the number? Of intersection F? So here on the numerator, what you do is a multiple of 5 and 20 both. So number of
Yes, sir.
multiple of 20 only, correct?
Yes, sir.
And denominator number of numbers multiple of 5. So number of 5. It means what if we do? We have to find out all the number multiple of 5, and out of that we have to find out which are only multiple of 20. So how do we get the multiple of 5?
The last digit must be either 5 or 0, sir. But
But
here we
5
only
is
have
not,
0.
yes.
So last
So
digit
what we,
must be fixed as 0. And the rest of
yes,
the digits can be any of the other 5 numbers.
yes. So 1, 2, 3, 4, 5. and there is 0
And
we fix. And
we can choose to omit any one number, sir.
but how do we choose? That's the important thing.
We can take different cases, sir, omitting 1, 2, or 4.
Very good. So you can take like 1 like and 3 unlike. Sorry, 1 unlike, 3 like, then 2 like of different kind, 2 like of different kind. Correct?
Yes, sir.
So the first case what we are making, 1 unlike
And 3 like.
and 3 like. We have done this kind of questions before also, like
Yes,
we are
sir.
constructing some numbers and
4
also what we get.
factorial by 3 factorial.
So what we are choosing, 1, 2, 2,
4
2,
ways.
correct?
Yes,
Yeah,
sir.
so 4 factorial by 3. Very good. Excellent. So that'll give you 4. Second,
2 like
you can
and
write,
2 of another kind.
yeah, same thing, 2 like, 2 like, just you write. So what do we get? 4
So
factorial by
2 factorial into 2 factorial, it should be 6. 6. Yes. Then 2 like and 2 unlike of different kind.
For example, I can take 1, 2,
But here we have to take
and
it
4,
twice,
4.
sir, since
Or we can also take like
1,
1,
4,
4,
2,
2, 2. Correct? So 2 unlike and 1, 2 like. So what we do there? You see
4
here.
factorial by 2 factorial.
No. There's a
2 into
problem.
4 factorial.
Out of 2 like sets, I have to choose 1. Yes or no?
Yes, sir.
So 2 like set and 2, 2, 2. Suppose you are choosing one of the like 2 2s or 3 2s, doesn't matter. It takes the same number of ways. So out of 2
Yes.
set of like sets, I'm choosing 1. So 2 choose 1, and into then after
4
choosing,
factorial by 2 factorial.
yes,
So it will be 4 factorial, which will be 24.
24. Correct?
Yes, sir.
Any other case?
No, sir.
No.
No, sir.
Really? But notice there's a 38p. So there's something you are missing, or some mistakes we are doing.
In the first thing, we'll have 2 different cases, no, sir. In the first,
How?
it,
First
the
one
one unlike
like
it can be either 1 or 4.
1 or
4.
exactly.
So
Very
it,
good. So
so it will be twice
here
this
become
minute.
2. Yes, twice of this. So it will become 8. And now it's
Now we are
feasible. That's the
getting
total
38.
number. Yes. So number of f is 38.
38.
Yeah. So sometimes you are missing.
for-
You have to see why they have given. Okay. Now we go for the 20. So when the
Yes, sir.
any number not divisible by 20, when the 1 will come at the tens place, correct?
Yes, sir.
So what we do, we'll keep 1 on the tens place and find out the numbers which are not divisible by 20, and
Then we can
subtract that
1
number
from the
from
total.
38.
From 1.
38, correct?
Yes, sir.
Yes. So numbers not divisible by 20 is easy to find. Numbers not
Yes.
divisible by 30. 20. And for that, I need this situation 1, 2, 3, 4, 5. So 1 and 0 I need here.
So 3 2s we can have, sir. First case.
First case,
3 like.
3 2s.
3 like. That will be
So this
only
is
one.
one case. Then, yeah, so one, we are taking 2, 2, 2. Then
2 like and 1 unlike. Which the 2 like can be either
So
2 or 4.
2, 2, 4 or 4, 4,
4,
2, correct?
Yes,
In
sir.
this case, I have 3 ways, 3 factorial by 2 factorial.
Yes.
And in this case also I have 3 ways.
So
total I
is
got
7.
7. So total
number of
answer
E
is
will
what?
be 31.
31. Therefore, probability of E given F is 31 by 38. So the answer 38, this is a P value. So 38P will be 31. So next question, this one. An experiment has equally 10 likely outcomes. Let A and B be two non-empty events of the experiment. If A consists of 4 outcomes, the number of outcomes that B must have so that A and B are independent. You know that if I say that probability of A intersection B,
0.
let me recall that. Independent. Independent means if the probability of happening of one event is
One
not
event
affect.
doesn't affect the other.
Yeah, so that's why I taught like that thing very categorically, that independent, what is the difference between independent events and mutually exclusive events? So you are saying the condition for mutually exclusive, correct?
Yes, sir.
So can you recall? If I have mutually exclusive, then you can say that probability of A intersection B is 0, because number of A intersection B is also 0, because A intersection B will become 5, correct?
Yes.
But when the independent events, then you recall probability of A intersection B should be equal to the PA into PB.
PB.
You understood now? Yes, remember.
Yes, sir.
Okay. Now tell me one thing. If A and B are independent, what about the A and B dash or B complement?
They'll be independent also, sir.
Very good. Now you recall everything. Okay. So PA intersection B is what? You can write PA into PB.
Yes, sir.
But what is this thing? This is probability of A intersection B is number of A intersection B by number of total sample space. And this side number of A by number of S. This is again number of B by number of S. Correct?
Yes, sir.
So we can cancel one number of S from the both sides and we get number of A intersection B is equal to
number of A into number of B by number of S.
by number of S, correct?
Yes, sir.
Now, number of A is already saying there's a 4 outcome. So this is 4. And 10 equally likely means number of S is 10, correct?
Yes, sir.
So we say number of A intersection B is equal to 4 by 10 times number of B.
Number of B.
Now, how do we find out that how many B this numbers B must have? How many outcomes B must have? There's a very important formula you have. What is called? Inclusive exclusive formula, number of A union B. What is number of A union B?
Number of A plus number of B minus number of A intersection B.
Can we use this?
Yes, sir.
How do we use it? This thing you know. Number of A you know, that is what?
4, sir.
4. Number of B is we have to find out.
Yes, sir.
Number of intersection B is in terms of
4 by 10
B only.
number of B. Yes, sir.
Now this total outcomes are what? 10
Should
equally
be less
likely.
than or equal to 10.
Yes. So this value should be lesser than equal to 10, correct?
Yes, sir.
Then we can get this idea. So what we get it here? 6 is greater than
6 by 10 B.
Therefore n of B is lesser than 10. But every number is lesser than 10. It's almost. Then how do we get it? See, whatever you're saying, I'm telling that. Think. Draw the Venn diagram and try to think. You have done this kind of questions before also. But can we think from the from the exact given information? I just suppose I have A intersection B some number, some integer. A intersection B is some integer.
Yes, sir.
So let A intersection B, the n of A intersection B is some integer, let's say m. So what we can do from here only, from there. This is some value m, and this is, I think, 2 by 5. And let's say NB is k. NB I'm taking as some number k. Then can we write 5m is equal to 2k?
Yes.
Now if 5m is equal to 2k, and see the options. If you take m is an integer number, m is integer, so m should be what?
Divisible
2k by 5. It means k must be multiple of 5, correct?
Yes, sir.
K is a multiple of 5. Otherwise, what will happen, that m cannot be an integer value. This positive
Yes,
integer, I mean, it's a natural number. So do you see the options what we have? 2, 4, 8,
5 and
3,
10,
6.
sir.
So the answer is 5 and 10. That's it. Correct? We don't have to think much question. Do you see? So maybe this is a very lighter version of the same concept. I'm not saying this is exactly same questions, but they are using the same concept, correct?
Yes, sir.
Again, they're asking that how many such ordered pairs of AB can be possible. Previously, they asked what is the number of outcomes in the B. Okay. So, what do you thought, Karnesh?
Both of them should be less than 6.
So basically what you are thinking, let me just take. So that the probability of A intersection B
is
is
probability
PA.
of B into probability of A.
So that is going to be number of A intersection B.
Yes, sir.
And that is equal to number of A, number of B.
Yes, sir.
So number of A, number of B, I think that is going to be 6 and it's 36. So I can write here 6, correct?
Yes, sir.
Okay. Now what do we think? They want to construct such kind of A and B so that A and B will become independent. So of course, this is the criteria we have already constructed. If any such numbers you distribute to A and B, automatically
Yes,
that will satisfy this thing, and then those numbers will give such pairs of A and B, correct or not?
yes, sir.
You understood my point? Yes. So what I'm going to do is, let's try to understand with some different scenario. There are many such other kind of solutions you find in different sources, but what I'm thinking, let me just convey here. So see here, there's a and B here. Let's say this is A as B, because A has bigger number of elements. Now, what I'm going to do, I'm just distributing entire thing into 4 parts. Let's say this total number is N. And let's call this as N1. Or let's say X. This is X. This is Y. This is Z. And this is W. We say that the N is equal to X plus Y plus Z plus W. Hello, Karnish?
Yes, sir.
Okay. Now you see, if you provide this X, Y, Z, W, automatically you are providing such values of A and B so that it is satisfying this one. Then you are distributing such a, like, let me just rephrase it. Okay. What I'm saying that, suppose you apply this condition. See here. Suppose you apply this condition, and according to this condition, you are distributing these numbers into these areas, X, Y, Z, W. So automatically such pair you are finding, A and B. So the number of ways you are distributing is actually providing you the number of ways you are finding the pairs. Under what condition? Under this condition. You understood this point? Okay. What I'm saying, let me just, suppose you are giving some values to here and here. Suppose you are giving this value 3, this value 2.
Yes,
and
sir.
why you are giving 3 and 2? Because
It should
first
be
of all,
divisible by 6.
But that is one criteria, but the other criteria is number of A should be larger than number of B.
Yes, sir.
Yes or no?
Yes,
Let me
sir.
write here. Cardinality such, because in the question they have used this symbol, so it should not be confusing. Okay. So number of A is larger than number of B. So suppose you given number of A is 3 and number of B is 2. And according to that, you distribute this thing. It means the number of distribution or the number of weight of distribution is providing you the number of such pairs of A and B. You understand my point?
Yes, sir.
Means when you take this A is equal to 3 and B is equal to say 2, in that case, it is not like only one possible A and B can be there. It can be many such cases, na? Because we have this thing 1, 2, 3, 4, 5, 6. You understand my point?
Yes. Yes,
So
sir.
how do we know that the A is taking 1, 2, 3 and B is taking 4, 5? How do you know that A is taking 4, 5, 6 and B is taking 2, 3? Because you are only providing A is 3 and B is
Yes.
2. So there are many number of ways you can find that pair by just giving A as this 1, 2, 3 and B is 4, 5, or A is 2, 3, 5, B is 1, 6. Are you understanding this thing?
Yes, sir.
Yes. So let me try. Let's say here, what I'm going to do is, I'm just giving the pair of AB. So let's say that number of A is small a and number of B is small b, correct?
Yes,
So
sir.
if you give number of a, small b, then what is the x value you can write? Tell me. X value is just AB by 6. Yes or no?
Yes, sir.
What is the y value? A minus x, correct or not?
Yes.
Sorry, b minus x.
B minus 6. Yes, sir.
And what is the z
Z,
value?
Z will be A, mi
B
A minus 6.
correct? And w will be
6 minus A plus B.
6 minus x plus y
A
plus
plus
z,
B.
correct?
X plus. Yes, sir.
Correct.
Yes, sir.
Is it clear so far?
Yes. Yes, sir.
Okay. Now the idea is that we have these are the placeholders. Let me just mark it. These are the placeholders of such no overlapping areas. And we distribute these 6 numbers among them and we find the number of ways of distribution of the 6 members, then automatically the number of ways we can find such ordered pairs of AB we have.
Yes, sir.
Correct? So let's just provide the ordered pair AB first. So I'm going to do is AB, and notice that the A is greater than B, correct? So first I'm
Yes,
giving it here 3, 2. 3, 2 means A is
greater than B.
greater than B. So can you tell me what is that? Will give you 1, correct?
1. Yes, sir.
If this is 1, then what we get it here?
1, sir.
2 minus 1, again 1. What we get it here?
2, sir.
2. And what is this thing? 2. Let's just
Yes.
add them now. 1, 1, 1. 1, 1, 2, correct? Now the
Yes.
idea is that we have these how many elements? How many is this thing? Total 6.
6. Yes,
This
sir.
total are 6, and you are distributing into how many groups? 4 groups. So number of distribution is what? 4 factorial, sorry, 6 factorial into 2 factorial, 2 factorial, 1 factorial, 1 factorial. Understanding why it is happening?
Yes, sir.
Okay, so if you don't understand, let's see. Out of 6, I have given 1 to that. Then 5C1 into 4C2 into 2C2, correct?
Yes, sir.
So let's simplify. So we get 6, then 5,
5, 4.
then again
3. 3 into 2.
no. How 3? 4C2 is what?
4 factorial by 2 factorial by 2 factorial.
So what we get? Again 6, na?
Yes, sir. 6, sir.
And then
3 factorial.
this is 1,
1.
correct?
Yes, sir.
So what we getting? 180. Is it clear?
Yes, sir.
Now tell me what we next we want to give. Can we give 4 and
3.
4 and
4 and 3 is the only possibility, sir.
yes. So what we get it here? 2.
Yes, sir.
So this will become
1.
come again.
1,
B
sir.
value is 3, so that is 1. Very good. What about this? 2.
2, sir.
Again, this will become 2.
1, sir.
2. 1. Okay, wait. 1. But again, we are arranging the same thing. 2, 2, 1, 1. So we get again 180, correct?
Yes, sir.
Are you understanding? Okay. Now, you can give here 6 and 1. Correct?
6 and anything up to 5 we can take.
Yeah, very good, very good, very good. So 6 and anything means 6 comma 1 or 6 comma 2, 6 comma 3, and 6 comma 4 and 6 comma 5. Now tell me one thing. The idea is this: there are many such other solutions. You can find it. There are such boring one. What we can think that this, whenever the A is taking 6 and B is taking any of the number, what is the meaning of this? If your A is taking 6 and total number of sample space is also 6.
Yes, sir.
So A has taken all of them. So what is happening there? That the P of A intersection B will become P of
P of P.
B only.
Yes, sir.
Correct or not?
Yes, sir.
And in this case, the whatever you take, the B, that will be always independent. Right? Because this side also will become, you see, PA intersection B, I need to prove that it is actually PA into PB, correct?
Yes, sir. And PA is 1.
PA is 1, very good. So we get that thing always independent. So you can say that A and B are always independent in that case, correct? By the way, we have already set up this independent case. We don't have to check it again, but that's just the way to understand that I wanted to say. It means what? Whatever the subset you take, because A has taken whole of the items, correct? So A is taking all the 6 items and B is inside it. So whatever subset you take for the A, that will be considered as B.
Yes, sir.
Means the B is any subset
Of A.
Provide but one thing. What is one thing you can see? That since
B is not
number
equal
of
to A.
yes, exactly. B is not equal to B. B is a subset of A, but it's a kind of a proper subset of A. Correct? B is not A. And also B cannot be, tell me one thing.
0. B cannot be null.
Empty.
Yes, sir.
Very good. So B cannot be null set. So you see, if I have a n number of items or n number of objects or n number of elements in a set, how many total subsets you can construct?
2 to the power of n.
N.
Yes, sir.
2 to the power n. So here I have how many total items? 6. So total we can construct 2 to the power 6. But out of this total, I have to remove the B not equal to A and B not equal to 5 case, correct?
Yes,
Means I have to remove B is equal to A and B is
2.
equal to 5 case. Minus 2. So that will become 64 minus 2.
62.
That is 62. So in this case, total 62. So we don't have to calculate much. And now the total number of total whatever required is what? 180
into 2
plus 180 plus 62. So that will become 422.
422.
And there is
Yes,
answer.
sir.
So you see the link that the IIT Roorkee, how they have taken one lighter version 11 years back, and then 2019 again they created a good question on that. Okay. All right.
Yes.